Adaptive damping mechanism. There are 4 degrees of freedom. The masses can bounce, there are friction forces along the x-axis, and there are variable dampers. Adaptive damping is the response to the third time derivative of the displacement in the x direction. The free body diagram for the airborne masses show that no friction is present. The free body diagram for the masses in contact with the surface, though, do have frictional components. The equations of motion for the airborne masses have no frictional components, whereas the equations of motion for the masses in contact with the surface do have frictional components. The initial conditions are to move the masses to the right and lift them off the surface. Let's take a look at these 3 coefficients and see how they affect the system response. The coefficient of restitution governs how much the masses will bounce. Delta of 0.9 has the most bounce. The coefficient of friction is most effective when the masses are in contact with a surface. Here, for a delta of 0.5, we see a significant impact of the coefficient of friction. And finally, the adaptive damping coefficient has a sizable effect on system response as it responds to the third time derivative of the displacement. Let's look at a video where there's no adaptive damping. Contrast this with a video where there is adaptive damping. It's much smoother. Thank you for your attention.